Hello and welcome to this video about theorems and proofs in linear algebra. In this video we'll be proving this theorem, that if A is a set of vectors that are linearly independent, then any vector in the span of A can only be written one way as a linear combination of the vectors in A. So I'll describe the statement of this proof more clearly, supposing that we have a vector y that's in the span of A. Then y can be written as a linear combination of the vectors in A. Here is an example of what it can be. y1 to yn are real numbers that, when used as coefficients of the vectors in A, produce the vector y like this. And these coefficients are unique. We can't have another set of coefficients that can be added together to make the same vector y. So here's an example, supposing that this is y. Then this set of coefficients can't produce y, even if only one of them is different. I've circled the coefficient that is different to make it stand out, and not to perform any special operation on it. And y isn't this sum of vectors either. So now to formalise this definition of linear independence. This set is linearly independent. If when a given combination of vectors is equal to the zero vector, this results in all of the coefficients being equal to 0, so no vector in the set is in any way the sum of the remaining vectors. So now to prove this theorem, which is straightforward. We'll define these two sets of coefficients to both produce the same vectors, even though the coefficients might be different. And to prove that there's only one set of coefficients that can produce y, we have to prove that these two sets of coefficients are equal to each other. So the first step is to subtract the first value of y from the second. And we could write it out more formally like this, adding y to minus 1 by y, which gives us y added to its negative, which gives us the 0 vector, which is this vector by definition. We've defined it in past videos. But subtracting one y from the other would give us this when expanded out in terms of the definitions, in terms of the vectors in A. Then we can gather like terms together like this. And then we can get these equations by using the definition of linear independence that we defined earlier. And then after manipulating all of these equations, we'll get all of these equalities, so that we've shown what's required to prove this statement up above. And thus we've proven this theorem that any vector in the span of A can only be written one way as a linear combination of the vectors in A. So I hope that you found this video to be helpful and educational. Please click like and subscribe if you did. Feel free to share this video and write any helpful comments. And thanks a lot for watching.